Okay, today we're going to go over section 3.3, which is called combining forces. So for this section, you're going to need, definitely going to need your calculator. So I have the TI-30XS, which was the one that was required for this course. If you have a different calculator, you'll have to investigate. I can show you how to use the graphing one, but if you don't have either of those two, you will have to research and find out how whatever calculator you're using has those specific functions that we're going to be using. So the functions that we're going to go through are the factorial, the combination, and the permutation. Permutations. Okay. So let's look at the factorial. What is a factorial? Okay, so the definition of a factorial is the product of all positive integers less than or equal to n. So that's the definition of a factorial. And I'll explain to you in English what that means. So notational, how does it look? Notational, you have an n with an exclamation. That is a factorial. So on your calculator, let's say that you want to compute 4 factorial. All right. So on your TI-30XS, you would have to type in the number 4 first. Okay. Then you got to locate the factorial, the exclamation point. So to find it on your TI-30XS, you would have to go to this PRB button right there. It's right below the mode. You can click on the PRB. And it's located on the 3rd line down. So you'll have to move your little cursor down 2 spaces. And then you hit enter. And there's your factorial. And so when you enter it, you should get 24. Okay. If you have a graphing calculator, this one, you pretty much do the same thing. You're going to type in the number 4 first. Then you got to find the factorial. Now this one's going to be a little bit tricky. So to find it in a graphing calculator, you'd have to go to math, right underneath the alpha, the green key. You go to math, and you got to move the little cursor to that PRB. So you're going to move it to the right 3 spaces. And you look for it. I think it's the 4th line down. So you have to move with the cursor down 3 spaces, hit enter, and then hit enter. And you're good. 24. So it works almost similar, but it's more difficult to find the PRB button on the graphing calculator than it is with the TI-30XS, because the TI-30XS is right there, right underneath the mode, the PRB button. So how is it computing 24? Well, you want to do it the long way. What's happening is you're starting, this is your starting number. You start with 4. And you start multiplying all the numbers behind 4 up through 1. So you're multiplying 4 times 3 times 2 times 1. That's exactly what factorial is doing. You're multiplying that number followed by all the numbers behind it. And hence you get 24. So that's the definition of what a factorial is. You're multiplying that number to all the numbers behind it, less. All right, so let's practice. Let's compute 7 factorial. All right. So to compute 7 factorial, you can do it the long way, right? We can do, if you want to do it the long way, I'm going to multiply 7 times 6 times 5 times 4 times 3 times 2 times 1. You do it the long way. That's pretty much how you're getting it. Or you want the calculator to do it. You would go in and press 7, the PRB, scroll down 2 spots, hit enter twice, once, 5,040. So folks, the material in this section is not hard unless you don't have that specific calculator. If you don't have that calculator and you have your iPhone, you're gonna have to research and figuring out how to find that particular function. So just letting you know, it's easy when you have this calculator or the other one, but it's hard when you have your iPhone. It's going to be kind of difficult. All right, so that's factorial. Okay. The next one is called a permutation. Permutation. Someone just said, what is permutation, sir? Is that when someone messes up your hair when you go to a beauty parlor? No, that's not a permutation. I mean, it is, but no. So a permutation definition of it is finding the number of outcomes where order matters, does matter. When you think about it, if you think of a combination lock, a combination lock should have been called a permutation lock, not a combination lock. In a little bit, I'm going to define combination. Combination order does not matter, but permutation does. So, I mean, if you have a combination lock, you have to put those specific, you have to dial the little turning thing, right? You got to do it in a certain order. It's got to be in order. So combination lock should have been called permutation. So, hey, you guys call master, the people in charge of the locks, and tell them, hey, your combination lock should be called permutation locks, not combination locks. All right, so notation. You have a capital P, and next to the P, the capital P, you have like subscripts. You have an N on the left and an R on the right. Right. So the N on the left represents the total number of items in the sample space. And the R represents the number of items taken at one time. And I'm going to put a little side note here. The N is always, I don't know how to spell always larger than N. R, sorry, larger than R. So you're gonna ask, well, how do you know which number goes where? Remember, the bigger number is always on the left side of the P. Bigger number, smaller number, always. If you have them backwards, you're gonna get a weird answer. We'll show you a little bit. All right, so let's practice. So you'll be asked to compute 11 P6. The permutation of 11 choose 6. All right, so on your calculator, right, you're gonna type in the left number first. You're gonna hit 11. Then you go to this PRB button again, and you look for the NPR, not the radio station, but there it is, NPR. You want to go ahead, it's already highlighted, so I'm going to hit enter. And then you have 11 NPR, and then you put your 6. And you hit enter. And wow, that's how much taxes I owe this year. So you get 332,640. Yes, it is a large number, but that's what it is. Again, so you're gonna type in the left number, 11. PBR, it's already highlighted, I hit enter, and then type in the right number, 6. On a graphing calculator, you do the same thing. You're gonna type in 11 first, then you go to math. You want to move your cursor so that PRB is highlighted. So I'm going to move to the right 3 times, and I'm going to choose number 2. Go down, hit enter, and then put your 6, and then hit enter. So you're going to have to use your calculator. All right, next one. 8 P1. All right, let's see if we can do it in my calculator. There. I'm going to click on 8. 8. 8. Then you do PBR. Enter. And I'm going to click on the 1. You get 8. What a coincidence. Weird. Now, this is what I was telling you about the rule right here. I was telling you about the N is always the bigger number, right? It's always a bigger number than the R. So if you had accidentally put 1 P8, let's see what happens. You do 1 PBR. You get 0. You know you did it wrong because you get a 0. But anytime you do it wrong, you do it backwards. See how the left number is smaller than the right one? No, this number has to be on the left. The bigger number has to be on the left side, and the smaller one on the right. Otherwise, you're going to get a 0. So that's how you know you did it wrong. Means numbers are back. Your N and your N and your R. Okay. That's permutation. Okay. Now we're going to do combinations. So definition of combinations. Is finding the number of outcomes where order does not matter. Okay, it doesn't matter. Does not matter. Okay, so let's say that your combination lock is 13, 24, 36. Right? 13, 24, 36. That's your combination lock, right? So do you have to put these in order when you open up your combination lock? Yeah, it does. You can't do 36, 24, and 13. It won't open. That's this in the order that it's in matters. That's permutation. If you do it out of sync, that's combination. So try it out. If you have a combination lock, it's not supposed to be combination lock. It has a specific order how you enter your numbers. You can't do it in any reverse order. It's got to be in that specific order. That is a permutation. Combination, it doesn't matter. It can be out of order. Out of order. And it'll, but there aren't any locks that are like that. All right, so symbol, you have a capital C instead of a P. You have the N and you have your R. So N, again, is the total number of items in the sample space. R is the number of items taken at one time. And again, N is always larger than R. So let's practice. So let's do 10 C5. 10 choose 5. Right, so my calculator, I'm going to type in the left number. I got on calculator first. 10. Then you hit your PBR. You want to scroll down to NCR now, not NPR, but NCR. Okay. Enter, and then you put the right number, 5. So you should have gotten 252. 252. On the graphing calculator, right, do the same thing. Type in the 10 first. 10. Go to math. Move to PRB. You want the third option. And then you put your right number, 5. And you get the same. So you really got to use a calculator. You really got to use a calculator for these things. All right, let's keep practicing. Let's do another one. Let's do 9 choose 4. 9 choose 4. So I'm going to put my 9. PRB. Go down. 4. 126. Okay, and what about 8, choose 2? That in 8 PRB. Choose 2. See it. Made it worse. I made it worse. You barely see it. But it should be 28. I believe it is 28. Sorry, the glare is bad. All right, so let's kind of review what we did. All right. So again, all we're doing is we're using three functions. We're doing the factorial. We're doing the NPR. And the NCR. Don't worry, we're gonna go through the word problems in a minute. And so we're gonna distinguish between which one do we pick? Which of these three options do we choose to use for our word problems? The word problems. All right, so let's practice. So how do we do, just kind of refresh your memory. So how do we do that in the calculator? All right, let's see if you remember. Do I use that button, or that button? It's kind of obvious, right? I'm gonna use that one, right? You remember how we did it in the calculator? Right. You have to type in the number first, then the function. PRB. That is the third option. Oh, I got a huge number. 3,628,800. How would you do 6P2? How would you do 6P2? Good question. So 6P2. 6. PRB. I want the P, that's already on there. And the 30. 30 is our answer. Next one. How would you do 7C7? 7C7. Let's do 7C7. Let me clear it. I'll put 7 PRB. I want the second option. So interesting what the result's going to be. It is 1. Weird, but it's 1. So those are the three functions that we're going to be using in a little bit, and then the next section we'll cover the word problems. All right, so now I'm going to go over another topic in this section, and that is the topic of repeating, non-repeating, using the fundamental counting principle. But principal, not the person who's in charge of the elementary school or high schools. No, but right. So the way to explain it is if you look at the lottery, you ever play the lottery, the numbers, you choose numbers. The way the lottery system works is very interesting. There's a whole bunch of games that you can play. You can play the Texas Lotto, Powerball, Mega Millions, Cash 5, Pick 3. Anything you want to call all or none. We'll investigate the let's investigate the Pick 3. That's a very, out of all the games from here, the best one to play is the Pick 3. This is the best one. These, oh no. Those are, their chances of winning are very, 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 very slim. So the way it goes is, all right, you have to choose, there's 3 balls that you have to pick. And the 3 balls range, and you have to pick, you have to choose numbers for each of those balls. You have to choose single digit values. You can only choose from 0 to 9. Those are your choices, 0 to 9. So how many choices do I have to choose for the first ball? Well, there's 10 because you're counting 0 as a number. 0 is counted as a number that you can pick. So you have 1 through 9, that's 9, and then the 0 is your 10th. Right. And the cool thing about this game is that you can choose the same number on all of them. So they can repeat. You can pick 333 if you want, or 777. So they're all going to be 10. You can choose. You have 10 choices, you have 10 choices, you have 10 choices for the third ball. So to figure out how many different number of possible different sets of numbers that you can choose, all you have to do is use your fundamental counting principle, and multiply those 10s all together. And that'll tell you how many tickets that can be generated by playing this game. So there are 1,000 outcomes. So you have 1 in 1,000, 1 in 1,000 to win, which is cool. I like that game. Now, if you play the Lotto, or one of those other ones, the Powerball or the Mega Millions. Now the Mega Millions I play the Mega Millions, but only if the jackpot is high, then I'll play it. But the chances of me winning are very, very, very slim. But hey, the chance is there. So to play Mega Millions, you cannot pick the same numbers. You got to pick different numbers. So the way it works is you have, there's 5 white balls And then you got a red one, the bonus, the Powerball. So for the first 5, you can only choose numbers from 1 through 70. And the Powerball, this one can be a different, it's a different color ball, of course. But this one you choose from 1 through 25. And so because you cannot repeat, no repeats, I have to choose for my first ball. I have 70 choices that I can choose from 1 through 70. But once I select that ball, I can no longer use it. So my choices decrease by 1. So the next ball I choose, I only have 69 choices because I can't use the same ball. And for the third one, I can't use the first 2 balls that I selected, so it decreases by 1. So that's why it's 68 choices. And so on, right? You cannot use, so you keep deducting an amount from the choices for the next ball and the next one. So this one is 66, I believe. Yeah, 66 choices. And this one is a different ball, so you have 25 choices. So notice if you compare the Pick 3 and the Mega Millions, this one you cannot have any repeats, no repeats. That's why these numbers are decreasing. But this one you can have repeats. So that's why these numbers are the same, because you can use the same ball. You can pick 777. You don't want to use the other number, but 777. Right. So how many different number of ticket sets of numbers can I choose for Mega Millions? Well, if I use the fundamental counting principle, multiply 70 times 69 times 68 times 67 times 66 times 25, and that'll tell you the amount of number of different tickets that we can generate. 69 times 68 times 67 times 66 times 25. And you'll see that if you multiply all those numbers, you get a weird number. On my calculator, it says 3.630942 times 10 to the 10th. What in the world is this? What is this number? Well, that is called, if you ever take science, this is called scientific notation. So I want to read it as a normal number, right? So the way you have to transform that into a regular number. So if you look at the power of the 10, because this 10 is positive, I have to move the decimal point 10 spaces to the right. Move 10 spaces, move decimal, sorry, decimal 10 spaces to the right. So I have to go 1, 2, 3, 4, 5, 6, 7. I'm gonna have to add 8, 9, 10, 3 more zeros. That's what that means. So I gotta move my decimal point 10 spaces. 1, 2, 3, 4, 5, 6, 7. So my actual number 36, 309, 042, 000 outcomes. So there are 36,309,042,000 different tickets that can be generated by playing this game. And from those 36 billion, how many are winners? There's only one. So the odds of winning, you have a 1 in 36 billion to win. Not good odds win. Hey, but if you think of it this way, you're donating to the education of our children and the politicians. So the point of this is that when there are no repeats, the numbers are decreasing. When the numbers repeat, they are identical. Identical, repeat, decrease for no repeats. And we're going to do an example of how this procedure works. All right, so here's the example. So a company wants to create badges to enter the building. They're going to give their employees badges. Company wants to create badges for their employees. To enter the building, of course, for security purposes, right? And they're only going to use there's five characters on a badge. 1, 2, 3. Well, there's four. Sorry, there's four characters that can be used to create these badges, and to create them, they can only use the letters A, B, C, and D. A, B, C, and D are the characters that can be used to create the badges. Okay. All right, how many badges can be created if the characters can be repeated? Right. In other words, A is good. You can use A. Okay. Or B, whatever. You can use the same letter once, twice, 3 times, 4 times. It don't matter. So how many badges can be created if we use those characters repeatedly? Well, since I have 4 characters and they can be repeated, so there are 1, 2, 3, there's 4, right? There's 4 characters. So I have 4 choices for the first character. And the second one can also have 4 characters, right? Because I can use AA, right? And this is 4, that's 4. So they're all 4s. They can all be repeated. You can have A. So how many badges can be created? So there's your number of choices. I'm going to use my fundamental principle, counting principle, and I'm going to multiply 4 times 4 times 4 times 4. And that's going to give me, what's another way of doing 4 times 4 times 4 times 4? Ah, someone said 4 to the 4th power. Ooh, I didn't think about that. How do you put that in the calculator? All right, so I'm going to press the 4, and then there's a little hat. Some of y'all may have the hat. Some of y'all may have the hat, or some of y'all may have X to the Y or Y to the X. One of those you have. typically it's the one with the hat. So you would type in 4 hat 4, or you can just multiply for it. That doesn't matter, right? So I'm gonna do 4. I'm gonna do 4 hat. Did I put the hat? Hat. I didn't do it. 4 hat. There are 256 total batches. Because they're being repeated. The characters can be repeated. Now, if we do the same problem, but it says that we cannot repeat. You can repeat the same letter, so I cannot choose AAA as one of my choices. I can't use those. How do I do it? Well, same thing, kinda. You have 4. So how many badges can be created if the characters cannot be repeating? All right, so you have your 4 characters, but they cannot repeat. So how many choices do I have? For the first one, I have 4. Right? But once I use one character, I can no longer use it. So I got to take one out. So now I have 3 choices. So let's say that I choose, this is A. I can't use A for this one, so I can only use B, C, and D. Right? I already picked a character, so then I can't use A and B. So now I have 2 choices, and then I have 1 choice. Right, so because they cannot be repeating, the number of choices start to diminish. Ah, that looks familiar. That looks very familiar. What mathematical operation had this, and then we multiplied it? Do you remember there was a function that we talked about that did 4 times 3 times 2 times 1? Do you remember what that was? Ah, that's right. Oh, the factorial. That's right. That's the factorial. You remember how to press that in your calculator? Let's see. So we're going to type in the 4 and we hit PRB. Scroll down. You guys can't see it because it's so dark. 4 factorial is 4 times 3 times 2 times 1. We get 24 choices. Right. So there are more choices if you have repeating characters, whereas if you don't have repeating, the number of choices is smaller. Right. Now, when we talk about next time, when we do the 3.4, I'm going to show you all the word problems, right? So the next time we're going to do the word problems, and we will doing the mathematical operation in the calculator is very simple. You just have to have the right tool, right, to do it. But going through the word problems, you'll have to be able to identify which mathematical operation are we going to perform. We're going to do the factorial, permutation, combination. So that's what we'll talk about on the next section, which is 3.4.